Let's take a look at section 5.3, where we want to look at special case factoring and a general factoring strategy. Our first special case we want to consider is factoring the difference of two squares. If A and B are real numbers, variables, or algebraic expressions, then the difference of their squares can be factored into the product of the sum and difference of the two quantities. So in other words, A squared minus B squared will equal A minus B times A plus B. So let's apply this to factoring 64x squared minus 36y squared. Now what I always want to do first in any factoring situation is look and see if there's a GCF. It turns out the greatest common factor of 64x squared and 36y squared is 4. So I want to factor that out first. So 4 times 16x squared gives me 64x squared. 4 times negative 9y squared gives me negative 36y squared. Now what I want to do in this next step is I want to write what's inside of the brackets as a squared minus b squared. So my a is 4x, because the square of 4x is 16x squared. B is 3y, because the square of 3y is 9y squared. And so now I'm going to apply the special case factoring formula. 4, my GCF just gets recopied, and a squared minus b squared is a, which in this case is 4x, plus b, b is 3y, times a, which is 4x, minus 3y. That's our b. So the GCF is multiplied times a plus b times a minus b. And notice it doesn't matter whether I put the subtraction first, as you saw in the formula, or if I put the addition first when I write the product of the two factors. And in my work of this, I actually intentionally put the addition first, since the subtraction was first in the formula, just to show that you could do it either way. All right, now the other special case is factoring perfect square trinomials. So if a and b are real numbers, variables, or algebraic expressions, then a squared minus 2ab plus b squared always factors into a minus b times a minus b. And notice that's actually the square of a minus b. A squared plus 2ab plus b squared is equal to the product of a plus b times a plus b, which is the same as the square of a plus b. So let's take a look at an example. Let's factor 25x squared minus 40xy plus 16y squared. So our first step in factoring should always be to ask the question, is there a greatest common factor other than 1? And notice there's no letter is common to all three terms, and there is no integer which divides evenly into 25, 40, and 16. So what we will see when we see that the first term and the third term are perfect squares. So in other words, I can write the first term as the square of 5x, and I can write the third term, and this third term must be added if this is going to be one of the perfect square trinomials. So there has to be a plus in front of that third term, and it also needs to be a perfect square, as this one is. So if the first term is a perfect square, and the third term is the addition of a perfect square, then if the middle term is either a positive or a negative 2ab, and notice in this case a is 5x, b is 4y, so if that middle term is, and notice this will be a negative because there's a subtraction of the middle term. If this is negative 2a, which is a is 5x, b, and b is 4y, so if that actually equals my middle term, I know what the way I've rewritten the first and the third term is equivalent. If I square 5x, I get the first term. If I add the square of 4y, I get the third term. But is the middle term, minus 40xy, is that actually equivalent to minus 2 times 5x times 4y? And you will find that it is. So this then will be a binomial squared. The operation in the binomial will be whatever operation is in front of the second term or the middle term. So there will be a subtraction here. A goes in the first position. A is 5x. B goes in the second position, and B is 4y. So if you were to actually square this out, and squaring it out would actually mean that you're multiplying 5x minus 4y times 5x minus 4y. And you would use the distributive property twice to multiply that out. All right, so this step is not necessary, but if you needed to show a couple of steps of work, these could be 2 steps that you would show. On your exam, I will be asking you to show work. All right, so here we're faced with factoring 9x squared plus 12xy plus 4y squared. All right, so we see that the third term is the addition, that has to be an addition, of a perfect square. The first term is a perfect square. If I square 3x, I get 9x squared. So the question is the middle term, and since the operation in front of the middle term is addition, there will also be an addition here. Is that middle term 2 times a, which is 3x, times b, which is 2y? So that's actually my question. So I want to check that that's actually true. Is 2 times 3x, which is 6x, times 2y, 12xy. And you would, of course, see that it actually is. So then this is the square of a binomial sum. Now notice I know this is a sum because that's the operation in front of the middle term. So the operation in front of the middle term always determines the operation of the binomial that gets squared. So this is the square of a, which is 3x, plus b, which is 2y. And it's important to remember that this means 3x plus 2y times 3x plus 2y. And I would have to use the distributive property twice to expand that. And when I do and simplify, I would get 9x squared plus 12xy plus 4y squared. All right, now another type of special case is factoring the sum and difference of two cubes. If a and b are real numbers, variables, or algebraic expressions, then the sum or difference of their cubes can be factored as follows. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. Notice there's no 2 here. So when I write this trinomial, it is actually prime. Unless there's a GCF that can be factored out, there's no other factoring I can do with this. So you don't want to confuse this with a perfect square trinomial. There's no 2, factor of 2 with the middle term. And a cubed minus b cubed is a minus b times the trinomial a squared plus ab plus b squared. So let's apply this to factoring 8x cubed plus 27y to the 6th. First step should always be, is there a GCF I can factor out? And it turns out there are no numbers or letters that are common factors of both terms. So my first step is going to be to write this as the sum of two cubes. So what do I cube to get 8x cubed? 2 times 2 times 2 is 8. X times x times x is x cubed. So this is the cube of 2x. And now I want to know, what do I cube to get 27y to the 6th? Well, 3 times 3 times 3 is 27. So one of the factors that goes in here for my b is 3. I need, when I apply this power of 3 to what goes inside of this parenthesis, I need to get y to the 6th. So I simply, to find the power that I need to put on y in here, I divide this 3 into 6 and I get 2. So if I cube 3y squared, I get 27y to the 6th. So according to the formula above, this is a plus b, 2x plus 3y squared, times the square of a, so the square of 2x, minus a, 2x, times b, 3y squared, plus the square of b. Okay, so that's what my formula tells me. I'm using the top formula. So I'm using this formula, the sum of two cubes. So notice the binomial factor always has the same operation sign as what I began with. So if I begin with the sum of two cubes, then the operation symbol in the binomial factor is a sum. And whatever this sign is, the first sign in my trinomial factor is always the opposite of the sign that the original problem began with. So the original problem had a plus. In the trinomial, the first operation is a subtraction. And here I've got a squared minus ab plus b squared. And I should do one final step to simplify that trinomial factor. So the square of 2x is 4x squared. 2x times 3y squared subtracted is the subtraction of 6xy squared plus the square of 3y squared, which is 9y to the fourth. And this is my final factorization for that. Okay, let's look at factoring 64m to the 6 minus 125 n to the ninth. Notice there are no letters common to both terms, and there is no integer that divides evenly into 64 and 125. So I'm going to write this as a difference of cubes. All right, so 4 times 4 times 4 is 64. So I've got a 4, and I know I'm going to have an m. And to find the power that goes on m, I take this 3 and divide it into the power of 6 that was in the original power on m in the original expression. So 3 into 6 is 2. So that's a power of 2 on the m. And remember, these two powers multiply when I apply the power to power rule. Those multiply. It gives 6. 5 times 5 times 5 is 125. So my b is 5n. And I simply divide this power of 3 into the power on n. And that's 3 into 9 is 3. And that tells me what power to put on n in my b. So I've now rewritten this as a cubed minus b cubed. My formula says that this is a minus b. So remember, the binomial factor always has the operation sign of the original problem. So there's a minus b times the square of a plus, this sign is always opposite the sign in the original difference or sum of cubes. So if I start with the difference of cubes, the sign, first operation sign in the trinomial factor is the opposite of that, a plus. Okay, here I have a times b and this third term in the trinomial is always plus the square of b. So plus the square of 5n cubed. And then I just have one more step to simplify this. No change needs to be made to the binomial factor. But I do want to apply these powers. So when I square 4, I get 16. When I square m squared, I get m to the fourth. 4 times 5 is 20. And I have m squared times n cubed. Plus, the square of 5 is 25. The square of n cubed is n to the 6. Alright, so you want to really make sure you get practice on this. It is a formula that a lot of times people mess up. Alright, and the general factoring strategy is to factor out any GCF different from 1 as your first step. If your polynomial only contains 2 terms, it could be a sum or difference of cubes, or it could be a difference of squares, as was our first example on this worksheet. Once I do that, once I factor out any GCF, and if I have 2 terms, perhaps what I have is a difference of squares, or perhaps it's a sum or difference of cubes. Perhaps factoring out the GCF was all I could do. Then I could have a perfect square trinomial. Or I might simply have a trinomial that I can factor with grouping, or which means I'm using the AC factoring method. All right, and so that's our worksheet for 5.3.